So one thing I forgot to mention about this exercise is I forgot to mention what the run arrow is. It's just something that I sort of know, and I forgot to tell everybody. So the run arrow is, in LabVIEW, on a front panel or a block diagram, there is an arrow here in the top. That's the run arrow. This executes your code. So when you hit the run arrow, the code that you've got gets turned into machine code and then runs on the computer. That's what compiles your program. And we'll learn more about that as we learn about LabVIEW. So we are just about to continue our journey. And what we're going to have to do now for the next hour or so is to learn about the LabVIEW environment so that you can make code from scratch on your own. You've already seen that you don't need to know any LabVIEW code to get a program that goes down on a computer and makes a robot run in teleoperated mode. If that's all you want your robot to do, you are done at this point. The next thing that you'll want to learn how to do is how to modify LabVIEW code. So we will look at the actual robot code in about an hour, but before we do that, we want to look at how LabVIEW works in general. So I'm going to set up a series of programs, 10 of them in a row that are very simple, that are additive. So you can't work on program number 4 unless you finish program number 3. Okay? And we're going to build up a vocabulary of LabVIEW functions for you that you'll be able to use to understand the robot code when we get to opening the robot code. So let's begin. What's LabVIEW? LabVIEW is a graphical programming environment. Lots of people like to say that it's easy because it's graphical, but just like any language, it is sufficiently complicated or sufficiently complex to solve all expressions that the computer can do. So it's just as complex as C, but it maps onto robotics problems very well because it's graphical and we use a physics engine or a physics analogy to allow data to pass through the program. So you're going to have functions that are these blocks of code that are pictures that look like what they're supposed to do. They're going to give out data onto wires. The data is going to travel along the wires between the functions, and then sometimes the wires will go to where the user can see them so that you can see the data that's on the wires. So this graphical programming language maps onto robotics problems very well because you're going to have signals come into the robot controller. They're going to come in through these functions. Those signals are going to pass around on the wires just like they pass around in the electrical wires to get into the controller. And then they pass out to go to things like the motors and the other sensors. It's a graphical program that's aimed at scientists and engineers, so this is also something that you'll be able to use if you become an engineer later. We've already talked about the Project Explorer. The Project Explorer organizes the code that's going to be in the robot. It also allows you to build the code appropriately, so to compile the graphical code so that it can run on the robot. Another thing that's important to know about the Project Explorer, and I'm just going to take a second to talk about this, if you want to share your code with somebody else, let's just say the FRC robot that we made earlier, this teleop code that we just made, this teleop code can be shared with somebody else. But if you just move the robot main part, that is not the whole program. The whole program is robot main plus the supporting code. So you have to move all of that code all at once to somebody else to get that to go onto another machine and run appropriately. Does that make sense to everybody? You can't just move robot main. So another thing that's important about the Project Explorer is that you can build, right-click, you can build from the build specifications section, not the robot boot up deployment, but from the build specifications, you can right-click and you can create a new zip file. So it'll take all of that code that's in the big, huge project, put it into a zip file, and you can give that zip file to somebody else. and then they can unzip it and all the code will be available to them on the new place. Does that make sense to everybody? So you can't just move the top part of the code to get it to go to another spot. And the way that you build a zip file or a source distribution is by right-clicking on the build specifications under the compact Rio target. Okay? It's a good thing to know. So the project window is important. It organizes where all of your VIs are. There are 3 types of files that will be in your project. The project file itself, which organizes where all the code is. The VIs are actually just programs. So we use the word VI because historically all programs written in LabVIEW were the virtual front face for instrumentation. That's not true anymore, but because we started calling them virtual instruments, we have to keep calling them virtual instruments, or our customers, some of whom are mature, they don't like it when we change things on them. So we don't just call them programs, we call them VIs, right? And then there are other things that you'll be able to see, custom controls, which we'll talk about more in a bit. The parts of program that are important. You have a front panel, which is the gray panel. The front panel is where that program it interfaces with a user, number 1, or with another program that it is part of. So if you've got a sub-function or a sub-program in a main program, it's going to interface to the main program through the front panel, which is the gray panel. So there's a front panel, which is the gray panel. There's a block diagram, which is where the graphics go and the wires that carry the data. Notice in this case we've got a couple graphics. What does this one do? Adds 2 things together. What does this do? Subtracts. So these graphics, you know, they will look like what they do. Data will come into these, so we get data coming into these functions, and then data will pass out. So I take A and B, and I add them together, and I get the solution. This is a terminal for a front panel object. So notice there's A plus B here on the block diagram. A plus B is there, and there's A plus B here on the front panel. So data will flow into this. Notice there's a little triangle there which shows you the data is coming into it. And then that will get shown to the user or passed out to the next program up the chain from the front panel. The front panel connects to another program through this thing called the icon connector pane. What this shows is that there are inputs to this function. Notice this function adds and subtracts. This is the graphical representation for that program. Here, this is called an icon. The connector pane portion shows that there are 2 inputs, probably A and B, and 2 outputs, probably A plus B and A minus B. So this graphic, if I pull it into another program, will have 2 inputs and 2 outputs. So what are the 3 parts of a VI? The front panel, the block diagram, and the icon connector pane. Parts of a front panel. Front panel will hold all of the input data to this program or subprogram and all of the output data. The input data will come in through what's called a control because the outside program is controlling what's happening, or the user is controlling what's happening. In this case, there is a knob here. I can control where that knob is set. So I can set the value on this control. I can also use the up-down arrows to change this 100 to be something else, right? So I'm in control of the program. That's a control. The other parts of a front panel will be an indicator. An indicator indicates what's happened in the program either to the next program up above it, to the main program, right, or to the user. So in this case I have a temperature chart that's being indicated to the user and could be sent upwards if that temperature chart were important. All right? Right now I can tell that this is not set up to be used by another program because notice in the connector pane there are no colors. If everything's white, then you can't use this in another program yet. It's just a program on its own. It doesn't connect to anything else. We'll talk about that more later. The block diagram, we're going to put functions on the block diagram that send data over wires to the front panel object terminals. You can tell a front panel object terminal because it's got that triangle input to it or that triangle output from it. So this was a control on the front panel. This was that knob. Notice it looks like a knob. It sends data out through this triangle onto a wire. That's going to go into a function that waits. This is going to grab a temperature and put it on the chart, right? Great. There are also structures in LabVIEW, which we'll talk about later. You can tell a structure from a function because a structure has an exterior space and an interior space. So anything that has an outside of it and a wall and an inside of it that's totally enclosed, this is a structure, and that structure is a for loop, which we'll talk about later. So there are functions, and there are wires, and there are terminal representations of front panel objects. Does that make sense to everybody? So you've got a representation of the control here, I've got a function here, I've got a terminal representation of an indicator, and I've got another function there. Data passes between them on wires. We'll talk about the icon and connector pane later, but the icon essentially represents the whole program that icon is a part of the front panel of. And then the connector pane tells you where that program can connect into and out of other programs. All right, so working with a program. When you make a program for the first time, you're going to go to the front panel, drop some items on the front panel, go to the block diagram, hook those front panel objects up to functions and to other items, and to the outputs that'll be on the front panel. In order to run the code, you'll have to hit the run button. The run button is the white arrow. There are other buttons up here that are not incredibly important for FRC. One button that I do want to bring up to you is the Never Touch Me Ever button. Don't ever touch this button, ever. It's the Run Continuously button, and you will never need it. I'll tell you what it looks like when it's pressed. You have an abort button. This abort button is like an ejector seat in a James Bond car. When you hit the abort button, you stop the code wherever it is. It's like a crash, right? So you want to avoid hitting the abort button if you don't need to. Usually, in the code that you'll be making, there will either be, it'll be a single cycle bit of code, and all you have to do is hit the run button. It'll happen once. Or there will be another button on the front panel which allows the code to know that you want it to stop eventually. When you hit that button, like the stop button, it will shut down appropriately. So there's an abort button, and then there are other buttons that allow for stopping, which we usually call stop buttons. Okay? If you want to, if you are anal, or your advisor is anal, I like to call these the mechanical engineering people, because I'm a physicist, and physicists don't care if lines are straight, but mechanical engineers, they really care. There are functions up here that allow you to organize your front panel. You can line everything up, you can make it all the same size, you can make things smaller or bigger, you can make equal distance between them, you can group them, all sorts of fun stuff. Just like you could in any program. And over here is help. So if you do need the help or you need to search for something that you've lost, you can search for it up here. Controls and indicators. I've already talked about it. Controls allow a main program to send data to a sub-VI. That'll happen through a control on the front panel of the sub-VI or the sub-function. All right? It's also something that the user can interface with if you're making a program that has a user interface. Indicators show what's happened in the code. They indicate what's happened. So iControl, or the main program, controls a control, and the program itself updates an indicator. It indicates what's happened in the block diagram. Does that make sense to everybody? Controls and indicators. Great. On the block diagram, you also have a toolbar. Has the same run button, the same don't touch me ever, ever, ever button, never touch me. Has the abort button. There's also a couple other buttons which can throw people for a loop sometimes if they don't know what they are. This is the, let me get my cursor back up for a second. There we are. This here is the pause button. If you ever see your code do this, and I'm going to continue recording, I come over to my code. If you ever see your code do this and start to flash, that means you're in pause mode. Pause mode is a great thing for debugging, but a terrible thing for running your code. If something like this happens, you're in pause mode and it's really subtle because see that's red rather than black? Pause is red rather than black. Turn pause off if you're ever in that mode. And I'm just going to finish out of this and unpause, and now we've finished. Does that make sense? That's what pause mode is. It's good for debugging because once pause mode is selected, you can single step through your code one piece at a time. So it's very helpful for advisors who want your students to do that sort of thing to know that that's available. Let's try to get you to your first code as quickly as possible. On the block diagram, you've got functions. You've got terminals for front panel objects like this we can tell is a control from the front panel because it's got an arrow out of it. This is a terminal for an indicator on the front panel because it's got an arrow going into it. If you are doing some coding and you want to know what something is, you can always right-click on it. Right-clicking is incredibly helpful. And usually when you right-click on something, one of the options is help. If you don't want to get that much help, you can use context help, which you can get through by hitting, and write this down, Control-H. Control-H gets you context help. So when you float your cursor over something, you'll see help like this for it. That's the full help that you can get by right-clicking. There are also, of course, examples that will get you started faster. And you can search these things. We'll talk about the controls palette and the function palette in a second. And quick drop. Okay, so let me show you how to make some code. We're going to start from a new VI, so we're going to close out of everything that we've done before because we're not really using the robot right now, so we don't need the big robot main project. So I'm going to close out of everything. We're going to try to do that as quickly as possible. Let's see if I can get this to come up. We're going to close that. Oh, this is trying to... Anytime that you have the option to save something, you should probably not save it if it's not something that you made yourself. So I'm going to not save a bunch of these functions that we're closing out of. We're going to get back to the splash screen. And so there's the splash screen. So if you close out of everything, this is where you'll get to. If you didn't get to here, you didn't close out of everything. What we're going to do to learn LabVIEW is we're not going to start from a project, we're going to start from a blank VI. When you open up a blank VI, which is just a program, you get several things. You get a front panel, you get, which is gray, you get a block diagram, which is white. You can also see that the block diagram says block diagram. The front panel says front panel. Okay? Anytime that you lose, that you don't know what to do, what should you do? Right-click. She's going to pass this class in the back. You can tell that was not learned helplessness right there. That was great. So whenever you right-click, good things happen. If I right-click on the front panel, look what happened. I get all these things I can drop on the front panel. Numbers, buttons, strings, graphs, all sorts of stuff. If I right-click on the block diagram, I get functions I can drop on the block diagram, including functions down here at the bottom that are about the robot. For right now, what I'm going to do, and I want you to nobody touch your computer right now, we're going to make the beginnings of a program that would be used in a robot to figure out whether or not something was too high or too low. How could this be helpful in your robot this year? Well, if you're looking at a goal that you need to shoot in and you're aiming at it, if you go too high, you might want to know that and then go lower. So we're going to use you as the sensor. You're going to be the sensor, the user of this program. So you are going to put a number into this program, and you're going to then have the program tell you what the number was. Okay? So I'm going to need a control. For instance, I could right-click and grab, because I'm going to, height is a number, I'm going to, and don't touch your keyboards. There you go. I'm going to grab a numeric control, and since we're measuring the height, when I drop a control on the front panel, I can type in a new label. If I ever lose or want to type in a new label again, so if I wanted to call this my height, rather I can just double click and start typing. So if I double click on the words, I can start typing. This is a numeric control. If I wanted to now indicate to the user what happened, what am I going to do? Where are my indicators at? Do I know where they are? Ah, I right click again, very good. And now I can look for things that might indicate numbers. So here's a numeric indicator. Does that make sense? Boom, I drop that. Notice they look a little different. It's a graphical programming language, so the graphics mean something. My control has an up-down arrow on it. I can control the number in it. The indicator doesn't. The control has a white background. The indicator has a gray background. Okay? So now I can say this is my measured height, and I click off. If I wanted to change the name of that, I can double click and start typing. Alright, so I want this program to run. I've got a new height. Passing 0 into 0 doesn't make a lot of sense, so I'm going to put in a my height of 5, and I'm going to hit the run button. The run button will compile the code and run the code. So we do that. And did 5 go across? Why didn't it go across? Because I didn't program it, right? It doesn't know what I'm trying to do, so I have to flip to the block diagram. You can either go to Window and Show Block Diagram. Notice you don't really have to hit to write the quick keys down. Control H is right there under Help, and Show Block Diagram is here. So I can show the block diagram. The cool Pepsi drinking young person way to do that, of course, is Control E. So I can go back and forth between the block diagram and the front panel. And notice I have to make a wire from my height to measured height so that the data will pass across the wire and into the new place. How do I do it? Where do you think the number comes out? At that triangle, right? So I float over that triangle. Notice my cursor changes to a spool of thread, and I click. Notice I think right-clicking is so important that when I mean right-click, I will say right-click. But clicking just means left-click, right? So I left-click, or correct, not right, because right, forget it. Okay, so I click, and I can make a wire. Now, anytime I click while making the wire, I can tack the wire down and change its direction, right? So I'm now wiring and clicking and wiring and clicking, and my data is going to go across this wire from one place to another. That's a ridiculous looking wire. If I ever find out that any of you have made a wire like this, I will graciously, professionally tell you that it's ridiculous. Okay? I can right click on the wire, as you would have guessed. I right click on the wire, and now I have to do my second step of right clicking, which is reading. And I'm like, oh, clean up wire. Look at that. And I can clean it up. Notice, by the way, that both of those will execute exactly the same way. It doesn't matter how badly you make a wire, it won't make it run any more slowly. But it will make it less readable. And you want to make your wires with as few bends in them as possible and to go from one place to another as quickly as possible. So we're going to now make code. You're going to make code as I come back to my basic training here. We're going to make code where you are a sensor. You input a number and pass it to an indicator. And I'm going to modify this as we go along and I figure out what people couldn't understand. Great. So we're going to stop the recording. Oh, there is a question. Yes.
Can you just show them a little bit about the auto tool, the different tools that pop up?
We'll do that after I've talked a lot, so I want to get them programming. We'll talk about that after, but I'll put it in my stuff to talk about right after we do this program. Okay, great. The question was about auto tool, and we'll deal with that one.